नमस्कार मित्रांनो, तुमचं पुन्हा एकदा स्वागत आहे मराठी AML या चॅनल वरती. मी आशा करतो सगळेजण खूप छान, व्यवस्थित आणि आहे त्या ठिकाणी खूप व्यवस्थित असतील. तर मित्रांनो, आपण ऑलरेडी फर्स्ट चॅप्टर ऑन द हँड्स ऑन मशीन लर्निंग आपण कंप्लीट केलेला आहे. त्याच्यामध्ये आपण द मशीन लर्निंग लँडस्केप हा फर्स्ट चॅप्टर कंप्लीट केलेला आहे. Now we are moving to the second chapter. Second chapter is about end-to-end machine learning projects. आणि I think खूप छान आणि असा इंटरेस्टिंग टॉपिक आहे. Literally, we are going to implement end-to-end machine learning project. Literally, and it's a step by step. It is not something that we'll get the data, learn the model, measure the performance, get the output. No, we are going very systematically, and it's again a long series. Don't skip any video. Seriously, don't skip any video. Watch each and every video. Probably I'm thinking that it may be 8 video series for this chapter, but I can't predict now. Okay, we'll see how many videos will come for this chapter, but today is the first chapter. And in the first chapter, uh, first topic I mean to say, in the first topic we are looking at the big picture, and this is a very much important. But prior to that, if you haven't seen my previous videos, which is a really building block of machine learning, where I have explained the main important topics, keywords of the machine learning, what is overfitting, underfitting, what must you have to do if it's overfitting, what you have to do if it's underfitting, cross validation, what do you mean by training data set, validation data set, train dev data set. Even I have given some kind of homework. Till now no one has posted that homework. No one has given the answer in the comment of the previous video section. So I really urge you everyone, please go ahead, look at that homework video, try to give the answer. If you already watched the first chapter of this book, okay, try to give it, submit the answer. Okay, will definitely, it helps to others to know what is the answer. Okay, so not wasting a much time, let's start the next chapter, and it is about end-to-end machine learning project. Thank you. Let's move. So what we are going to see in this chapter, first let's look into that. So these are the topics we are going to see in this chapter. First is look at the big picture. Okay, so we have to understand what is the problem statement and what it is that. So this is very much important, guys. When you are going to work on any machine learning project or any data science project, it is very first important point that you must have to understand what exactly that problem it is. Okay, and today our whole lecture in that only. We are not directly jump into the get the data. It is very most important to first understand the what is problem. Okay, and then you are going to go and collect the data and do the visualization. And let me do get the data, then you will going to do the visualization to get the insight from that data, then prepare the data for machine learning algorithm, then select the model, which model is best fitted for the data, and train on it. And after the training is done, you will do the performance measure, means the matrix calculations, and based on the performance you fine tune your model, again train it, get the result. And once you get the result, you present the solution. Once the solution is accepted by the team, by the product manager, or by the client, then you launch it, you monitor it, and then you maintain your machine learning systems. So these are the big steps in any machine learning system. Might be some interview you got this such a question, what is the high level picture of any machine learning building block? So first look at the big picture, get the data, discover and visualize the data inside, then prepare the data for machine learning, select the model, train it, then fine tune it, present the solution, and launch and monitor and maintain your system. So it is very important, guys. Don't look at this as just to get the theoretical knowledge up. This is very much important when you are doing the practical ones as well. Okay, let's move to the next point. Okay, let me clear this screen, clear this drawing. Yeah, so now very much important. Whenever you are working on any machine learning problem, before we are looking at the data, just I wanted to give some of the important points. When you are working with the real data, it is very much important to get the data. Okay, and to get the data is very again a time consuming task if you are going to do the manual. Okay, and it is very kind of, you know, you have to search in many of the website to get the data. So I'm just giving here some of the references. Again, this is copied from the textbook, not mine, but these are the some references. It's really helpful if you want to build some kind of POC or some kind of prototype, okay, for any machine learning problem. So these are the you know, website. So first popular one is the UC Arvin machine learning repository. Just search with this name, you will get the website. Kaggle dataset, I think most of you guys know what is a Kaggle datasets. Kaggle website, there you can find the dataset. Second is the Amazon AWS dataset. So in that website also you got the you will get the Amazon from the Amazon website. Next is these are some kind of portals. Okay, website link, it's already given here. One is a dataportal.org, second is opendataMonitor.eu, so it's a European websites, and this is a qquendel.com. so from this website also you get some of the data. Next, second, yeah. Next, these are again few websites: Quora websites, subreddit websites, Wikipedia, machine learning datasets. So from this website also you will get the datasets. So this is just for references. Now let's come to our problem. So when we are developing end-to-end projects, it's very important to understand what the problem it is. And our problem is something based on the housing price prediction. So what happened, we are working in one of the real estate industry, and in that real estate industry they hire few data scientists, and we are one of the data scientists working there. One day my boss came to me and he asking me, hey Sai, can you develop one of the machine learning model, okay, where I wanted to predict the price of the housing, price of the houses in the district of the California. Now if you look at the screen, in the screen this is the this is the California map. Okay, and this California map is a consist of many areas. If you see these, so these areas are nothing but the districts. Okay, and our aim, my boss wants to know what is the price of the house who falls in this district, who falls in this district, who falls in this district. So this is the problem statement. Now I hope now you understand what is the problem statement. Let's jump to the next part. Now, as I said, our first important point is look at the big picture. Now, as of now, we understand what is the problem statement. Now, this is what problem statement I already described. We have to build some ML model, okay, and that ML model will do the prediction of the housing system. And I already described what is mean by district. So I have shown you the graph, and in that graph I have shown you the what means by district. District is nothing but the some group of the you know, some blocks in the map of California, and that each district consists of 600 to 3000 people. Okay, so this is the problem statement. Now it is very important to first, and you know, to ask a question. Okay, this is again one of the very important skill set that every data scientist must ask you know, to the boss. Okay, now we understand the problem statement. Our problem statement is to predict the house of the price within that district. Now you must ask the first question, that what is the business objective. Okay, if I build the machine learning system, if my boss is asking me that build this system, but what is the objective? Okay, what business gets benefited from this after building this machine learning model? Again, if I build this machine learning model, how company gets benefit from this? Okay, so these two questions are very important question you can ask for any such a machine learning problem. Okay, one is the business objective, and second, how the company gets benefit if I build a machine learning system. Now question comes in mind, why shall I ask, okay, this question? Because when you ask this question, it will help the data scientist to predict what algorithms I must have to select. Okay, what algorithms I must select based on the once they describe the objective. Second, I'll able to find out what will be my performance measure. So when I say performance measure, means once I build the ML model, I should evaluate that ML model, right? Okay, so on what basis I must evaluate? So for that, I must require some matrices, some performance measurement, right? And third, how much effort I'll require. Am I able to do it single-handed, or am I require few members? So it will depend on how much problem is big. It depends on what is objective of the problem. Do they require only simple things from my ML model, or do they expect something big? So depend on that, I can formulate my the efforts required for this. So these are the two questions, guys. First, objective, and second, what company gets benefit. And when you ask, you will get the three things. That three things will help you, that is algorithm selection, performance measurement, and how much efforts you require to spend. Now let's jump to the next. Okay, now when you ask this question, your boss is giving this answer that, okay, your question is good, let me ask you. So boss answer that we want to build this machine learning problem to to do the machine learning pipeline for our real estate system. Now you confuse what is pipeline. I'll explain in a bit. So they want, we will get the data from, definitely from census data. Okay, we want to deploy this data into the database, and based on this data we want to print the pricing. Okay, I build the machine learning, then you will get the pricing. Based on that price, again I'll pass this, I store this data into one of the database, and from that I will do the investment analysis. Okay, and based on that I'll do the investment. So if you see the diagram here, I'm building the two machine learning model. One is for the district pricing and one for the investment analysis. So my boss is saying we want this kind of system in place which will help me to predict the price of the house, along with it will answer me to do the investment. Okay, so this kind of pipeline called as a machine learning pipeline. Now this is also called as a data pipeline, because here you always take the data from the raw data and prepare that data for the district pricing. Again, you collect the data from district pricing and prepare for the investment analysis. Again, you refine that data and store into the investment. So this such a kind of pipeline also called as a data pipeline, because each pipeline, each component is dependent on the previous component, and when you join these components together, this is called as a pipeline. I hope you understand. So now we got what is the objective of the business, right? So somewhere we got some hints that they want to build such a pipeline, but still the question is that how the business get benefit out of this, right? Okay, before that I'll explain you in the second coming slide, but before that there are again two questions are there. The question will be that what the current solution look like, right? What the current solution look like. Now I understand. So my boss is giving me, we want us building a machine learning. So somewhere I got the hint that he wants some he wants some automation process that my machine learning help to build the product. But now question comes in my mind, what is the current solution? How the current work is going on? Okay, so when you ask this question, this again help you for to do the performance measurement, and also it help how to solve that problem. Okay, because you build the machine learning problem, but you must have to understand what the current solution is, and based on that you develop your algorithm, right? So your question second is that what is the current solution look like. So as of now we have three questions. First is what is business objective, how the ML model get the benefit out of this, and what is the current solution look like. Let's move to the next. Now answer is given by my boss is that currently the current solution is that the housing price are currently estimated by the manually. Okay, so there are few experts in the real estate industry who who will help to build the pricing, that what if I build any building or any infrastructure related stuff in that particular district, then this will be the pricing for that house. So it's a manual process, but due to this manual process, it's too costly, it's too time consuming, and the performance also not great, because as it's a manual process, so we are dependent on the human beings. And it's again because when they estimate the price, they require a lot of things, lot of analysis, and it again a time consuming. So by that time, maybe opportunity to invest in that particular district may get, may get away, okay, or may get erased. Okay, so it's very important to, you must have to do this very quickly, so we can do the investment fastly and we will get the profit out of that. So when I understand, then I come to know, okay, this is the business objective and this will be really helpful for the cost saving, right? So I come to know, okay, now I have to build this model. Okay, next point. Okay, now this based on the question, right? This based on the question. Now I have, based on the answer or based on this discussion between you and your boss, now it is very important to categorize these three things. So first, it is a supervised, or it is a unsupervised, or it is a reinforcement learning. Okay, I already explained these topics in my first set of videos, okay, where I explained in very detail. Second question I'll ask to myself, is it a classification problem or the regression problem or something else? Should we use the batch learning or the online learning technique? Okay, so these are the questions I should ask myself. Now, first moving to the next slide where I have to keep all the answers. So take a pause and based on till this slide, think whether it is falling on the supervised or unsupervised or reinforcement learning, or whether it is a classification, regression, or something else, or what kind of learning we use, batch or the online, and try to give the answers. I hope till now you answer all these three questions. So not to waste much, let's check whether you answer correctly or not. Okay, so based on our discussion between me and my boss, I understand this is clearly supervised learning task. Now, why it is supervised? Because I have the label training data. How? I collected the data from census, right? That is collected from one of the stats library. When we check for the how get the data, I'll show you that. Okay, but it is supervised because it contains the label training data. So I have some of the features here like longitude, latitude, or the population, then income within that districts, and then last is the target data. Target will be the house price within that district. Okay, so it is a label data, therefore it is a supervised learning. Second, it's a regression task. Why it's a regression task? Because here I'm predicting the value. I'm not doing any classification, whether it is a dog or cat, whether it is a category 1 or category 2 or category 3. It's purely a regression task because I'm predicting the value. Again, it's a univariate regression problem. Why? Because I'm only predicting the one value, that is the price of the house. If I'm trying to predict the multi-values, price of the house or the dimension of the house or any etc things, then it is called as a multivariate regression problem. Guys, please remember this keyword because it's very important in machine learning stuff. Okay, I am predicting the only one value, therefore it is a univariate regression problem. Next, it is a batch learning. Why it is a batch learning? Because I don't have, I'm not getting any continuous data. The data is already stored in the census data. Only I'm collect that data and use it directly. I directly feed that data to my ML model. So it's a kind of batch. Again, it's a small and the data is not changes rapidly. So I do not go with the online learning where my data changes continuously. I'm feeding the data to my ML model. Therefore, I'm not going with the online. It's a batch learning. So as of now, I got that these three things. It's a supervised. Again, it's a univariate regression problem and it's a batch learning. Now next, because of it's a regression problem, I'm using the best performance measurement in the regression, that is called as a RMSE. RMSE stand for the root mean square error. RMSE stand for root mean square error. Don't worry, I'm going to explain in detail in upcoming videos, but just to give what is root mean square error, where I'm calculating the distance between the actual value, okay, I'll minus that actual value from the predicted value. Okay, suppose my actual house of the X country, X state is a 1200, okay, and my predicted is the 1000 or 1300. So my 1300 minus 1200 is 100. So my model is giving 100 as an error. Okay, so this much of, so I must have to know that my model is performing well or not. If it is performing well, then how much error I'm getting. So now I understand my error is 100. So what will be my next process? I have to fine tune my model, so my error of 100 is getting reduced and it is more close to 1200 or rather than 1200. Okay, this is my measure. So this is RMSE is called as a root mean square error. Now let's understand how this root mean square error works. So till now, I hope you understand what I'm trying to say. Okay, now if you look at this root mean square error, which is my performance measure, okay, because this is very important. M is nothing but the number of data set available in my census data. Now probably if you look at, this is something look like my data set. Here I'm just giving one sample, but this is my data set. So number of data means number of rows. Number of data set means how many number of rows are available, how many districts are available. So if my district, let's say I'm consider ABC is my district, this is my longitude, this is my latitude, this is my inhabitant means number of peoples living there, and what is the median income of that district, and this is my price value. So here this is called as a label and this stuff is called as a feature. Now when I have the label, this is called as a supervised learning. Now, so M is nothing but the number of data sets available. In short, number of rows are available. Let's consider I have the 2000 information, 2000 rows are there. Now, Xi, what is Xi? Xi is nothing but the vector of all the feature values, excluding the label, and I stand for the ith instance. When I consider my first instance, so I becomes 1 and X stands for the vector information. Vector means what is the longitude? Vector, I mean to say, see, when we are doing the any machine learning problem, we will go with the mathematical calculations. We cannot go ahead with the string type of, because machine learning internally works on the mathematical data. So it will do the matrix calculation. So we must have to provide the information in a matrix way or in vector format. Then only it is possible matrix calculations. Understood? So these are the feature. I'll convert into the vector format. So my first information is 118, second is a 33, next is a 1416, and the next is a 38,372. So I'll store this information in vector format. So this is my first instance of X. Similarly, there are XYZ, CDE, many districts are in the California. Accordingly, I have the information and I'll store in the vector format. Where, however, I'm not including my target value into the Xi. I store that target value into the yi, which is we call as a label. So my y1 is a $1,56,400. This is a dollar value, not a rupees. Okay. So when I pass this information to my, so I know the yi. How I can calculate the yi? Y is a 1,56,400. So when I pass this information to this, it will give me the y hat. Okay, let me explain. I have explained this in next slide. Okay. Okay. So I know my yi. My yi is 1,56,400. When I train my model is giving the hypothesis information. My y giving this. So X is the matrix containing all the feature excluding label, where H is your system prediction. So whenever my model predicts, it store into the H of Xi. Okay, so I passing my Xi value to the H means hypothesis, that means to my model model will predict and it will store into the y hat. Let's say my y hat predicted the value 1,58,400. So when I do the subtraction, this is something comes around the 2000, right? But this is only simple subtraction. You must have to do the squaring, and then you have to take the all data points and then divide by average. This is called as a root mean square. Now if you look at the x contains my all the first instance, second instance data, third instance, and the till 2000, because I'm considering the my m is 2000, means total number of rows available in my data set. Now I'm doing transpose. Why I'm doing transpose? Because my vector contains information like this. Okay, and now if I want to do the calculation, I have to make the transpose, means my column becomes rows. Okay, so my first instance information here, my second instance information here, my third instance till my 2000 instance till this way. So this is called as a, this is something called as a root mean square error. I hope you understand what is the m. M is nothing but the number of instances. Yi is my actual value. My h of xi, which is nothing but the y hat, is my predicted value. When my minus, when I do the subtraction from my actual value to the from my predicted value, I'll get the RMSE by doing some squaring and the square root and then average. Okay, so will it be only one performance model is available in the regression? No, we have multiple type of performance metrics are available. Another matrix called as a mean absolute error. But why RMSE? Because RMSE is preferred in the regression task mostly. Okay, there is a reason it's most popular. That's why I have explained RMSE. But there are others also like MAC. Okay, mean square error is also, and another is a mean absolute error. What is the difference between the mean absolute error and the RMSE? In the RMSE, as name is suggests, we are taking root mean square, means square root, and we're taking the mean and then we do the square root. But in the mean absolute error, we are taking absolute differences between my actual value and the predicted value. So now the confusion comes when to use MEE and RMSE. We use MEE, that is mean absolute error, when we have outliers. Okay, when we have outliers, then use mean absolute error. I already explained what is outlier. If you don't know, please watch my previous videos. Okay, so if data contains outliers, then use MEE. Because why? Because MEE is very robust to the outlier. It will not get, there will be no effect of outliers on the mean absolute error matrices. But okay, if there is no outlier, then please go ahead and use the RMSE. Okay, next. Now, let me just explain a bit about the RMSE and MA. Now, RMSE is normally correspond to the Euclidean norm and ME correspond to the Manhattan norm. What is Euclidean norm? Now, there is a difference between the Euclidean, because see, RMSE or ME, okay, at the end, they measure the distance between the two vectors, right? Which two vectors? That is yi and y hat I. Okay, so suppose this is my predicted line and this is my actual price. So what error means? Error is nothing but the distance between this point and this point. This is nothing but the error. So it is calculating the distance between the actual and the predicted one. But when we are doing RMSE, they internally using the Euclidean distance concept. Okay, or it is normally called as a L2 norm. And when we are using ME, they are using Manhattan distance concept to calculate. Now, I'm not going in much detail what is the difference between the Euclidean distance and Manhattan distance. You can refer the YouTube if you wanted to watch about that. But in short, I want to explain the Manhattan distance is absolute distance, means it is, you can relate with the going by road. Okay, if I want to travel from Pune to Bangalore by road, then you have to visit many stations. Okay, and you have to go by road. But when it is RMSE, it is a Euclidean, and to calculate the Euclid distance, they internally uses the Pythagoras theorem. Okay, in Pythagoras theorem, we are calculating the hypotenuse. Okay, so it is normally, if you know the triangle, okay, so this much A, B, C. Okay, so AC, if I want to know what is the distance, so AC will be the distance for the Euclidean norm, because AC square is equal to nothing but the AB square plus BC square. And Manhattan, if I go with the Manhattan, it will visit A, then B, and then C. Okay, I'm not going in depth, just watch it. What is the difference? I'll keep this as a homework, watch it. And if you know the answer, just give the comment. But as it is, as RMSEs correspond to the Euclidean, so it is very sensitive to the outliers. Okay, it is very sensitive because we are calculating the resultant vector. Okay, and resultant vector, it's all depend on your adding components. If your adding components contain outlier, your resultant vector also changes. But this is not the case with the Manhattan. Okay, it will not depend on the outlier. And in the outlier, due to the large value, it neglect the small one. Therefore, RMSE is more sensitive to the outlier. That's why we use MAE when it contains the outlier. So as of now, I hope you understand that RMSE perform very well with the regression task if doesn't contain outlier. Otherwise, go with the MAE, because MAE is based on the Manhattan and RMSE is based on the Euclidean. So I think now we understand what is a problem, right? So our problem is to predict the house of the price. What is the objective? Because my system, my estate, my company, real estate company wants me to build a machine learning program that helps the manual process of estimating the price, and that will help me, to that will save the company cost. Okay, after doing this, there are few assumptions. Okay, you must have to recheck the assumption. Like, it is always good to list down those assumptions. What are those assumptions? Okay, otherwise what happen, if assumptions are not correct, there may be a issue. You are wasting your efforts. Okay, and you must cross verify those assumptions between you and your team. Why I'm saying assumption is correct? For example, probably there will be discussion between your boss and another team member. They do not want to do the prediction of value. They just want to predict the whether that district contain the cheap price, medium price, or expensive. So when that is the assumption between your another team member and boss, where they agreed, and you just building a model for the prediction of price, then there will be a conflict and your ML model will be not good. Because when you do the this kind of classification, then it is called as a classification algorithm, and altogether your performance matrix also get changed. So it is very important to first understand what are these assumption and list down. I hope you guys you understand our first topic. In our next topic, we are going to focus on get the data. Okay, we are focusing on the get the data. As of now, we understand what is a big picture of our this machine learning problem. Till now, thanks for watching and all the best.